So it said to find the z-score that corresponds to a cumulative area of 0.034 and 0.0384. And they don't say this, but they should say this, is that if they don't indicate it, they're understood to be areas to the left. So what this would mean, we can draw our normal curve, and it would mean that we're looking for the z-value that gives an area to the left down here of 0.0384. So we're going in reverse. We have the area or probability. We want to find the z. So what you would do is what's called an inverse norm. We talked about this in 6.1, just as a quick reminder. The problem with the inverse norm function in your calculator is it always wants an area to the left. So just as a reminder, it will only take an area to the left only. But that's okay for this particular one. We already have an area to the left. It's 0.0384. So if you go ahead and plug that into your inverse norm, it will go ahead and calculate your z-value for you. So go back to your calculator, do your inverse norm of 0.0384. And what you get is negative 1.77, and that is your z-value or z-score that has an area to the left of 0.0384. Now let's continue right along and continue with doing the same type of things, but let's look at percentiles. So we want to find the z-score or the z-value that corresponds to a 55th percentile. Well, let's remind ourselves what a 55th percentile means. It means that 55% of the data is below your value. Well, remember that percentages and probabilities are close. Probabilities are just the percentages as decimals, so that would be 0.55. And that's also the same as your area. So that would be the same as saying I want an area of 0.55 to the left. So if I want to find the z-value, like they're asking for, all I need to do is work in reverse. I need to use an inverse norm again. Luckily, percentiles automatically mean the area or percentage below you, so that 55% is already to the left. So I can just go ahead and plug in the inverse norm of 0.55, and let's see what our calculator gives us for that value. What our calculator gives us is a 0.13, and that's our z-value. That represents the 55th percentile, meaning 55%, or 0.55 of our data is below this z-value of 0.13. Let's do one last problem